this demonstration, we're going to illustrate the concept of electromotive force and the concept of electrochemistry and batteries. Now, what's very typically seen in a textbook when we're looking at the concept of batteries and electromotive force is a drawing of what's called a Daniell cell, which was one of the first electrochemical cells used to actually do something. It was used in the 1800s to power telegraphs before electric dynamos were invented. In this particular concept, we have a cell where we have a piece of zinc metal put into a beaker of zinc solution. In this particular case, what we're going to do is a zinc nitrate solution. In this particular, what we call a half cell, the oxidation half reaction is going to occur, the oxidation of zinc metal into zinc ions. In the other compartment that we have, and we have it illustrated right here as well, is we have a copper 2 solution with copper nitrate, and we have a copper electrode sticking into the solution as well. And in that particular compartment, we're going to have the reduction of copper ions picking up electrons from the zinc compartment to plate out copper on that particular electrode. Now, this is the overall reaction that's actually going to occur. We could do this reaction in a single cell. If we put a piece of zinc into some copper solution, this reaction will occur. However, the transfer of the electrons will occur directly on the surface of the zinc, so we won't be able to get any work out of it by the movement of electrons. If we separate the half reactions with these compartments using a salt bridge, the salt bridge will allow the ions to balance out the charge difference, so we'll maintain electrical neutrality, and we'll be able to tap off the electrons moving from the zinc, what is called the anode, over to the cathode, where they can be collected by the copper ions and plate out copper onto the electrode. This compartment, the zinc, where oxidation occurring is the anode, gets its name anode because anions are flowing into this compartment. The cathode's called the cathode for the same reason here. The cations from the salt bridge are flowing into this particular compartment. And again, if we separate the compartments, it will allow for the transfer of electrons through the wires, in this particular case to a voltmeter. Now, the voltmeter is not actually going to tap any energy out of this. We could leave it hooked up to this cell basically forever, and it would read the same voltage. We're not taking any work out of it at all, the way the voltmeter works. So I'm going to hook these up right now, like so. And then I'm going to hook up here, and this will allow the electrons to go through the voltmeter like so. And right now, hopefully you'll be able to see the voltmeter. It's reading about 0.67 volts. The theoretical voltage on this, if we have both of these at 1 molar concentration on here, is 1.10 volts. There's all kinds of reasons we're not getting that. The temperature can be different, concentration's different, the internal resistance of the cell itself, but we can see we're definitely getting a voltage there. With the salt bridge, if I remove the salt bridge, the voltage will go down to 0 because there's no way for any ions to be balanced between the two solutions, so the voltage will cut off immediately. On there, as you can see, we went down to 0 volts. We put it back in there. It allows for electrical neutrality to occur, and we'll get the voltage right back. The voltage coming off of this is what we call an intensive property. Depends on the chemicals that are being used. For example, if we had cells the size of this room, right, and we would have the same voltage on here, it wouldn't make any difference. The voltage is what's called the potential difference. It's a property of matter. Now, water is a great way to illustrate the concept of voltage and current. The voltage or potential difference, it's really the concept of water over a waterfall being a potential as well. If I start here and I pour the water at a constant rate like that, the rate that the water coming out of there is relative to the current. The higher the water flow, the more current that you have. But the height of the beaker is the voltage. So if we say that this is 1 volt, if I hold it twice as high above the sink, pour at the same rate, that's 2 volts, right? Whereas the current, if I hold it here at the 1 volt mark, this is a low current, same voltage, but a higher current coming out of there. And that's really what we're seeing in these commercial batteries as well. If you look at these two batteries in particular, this one is a AA cell, alkaline cell. Alkaline refers to the electrolyte that's actually used in here and to allow the ion transfer. And this is a C cell right here. If you read the voltages on them, the voltage is exactly the same. It's 1.5 volts. That's because they use the same chemicals in there. But what you should deduce from the water experiment is that the current is different. The C cell is able to provide much more current, and then therefore would be used for applications where you need to have a higher power requirement than you do with the AA cell. So this is very often used like for a boombox, for music players, where these guys are more commonly used, like in a calculator or in a clock or something like that. Now this particular one is a 9-volt battery. And if you look at the electrochemical series, which is what you use to predict what the voltage of certain chemical combinations are going to be, none of them produce 9 volts. So you're going to wonder, well, how do you get a 9-volt battery? Well, it turns out that these guys use the same chemicals as we have right here. So as you might imagine, there's essentially 6 of these crammed in to here, hooked in series. And when you add the voltages together, you get 9 volts. So you can also, because of its size, you not only up the voltage on here because you have 6 of them in series, but you get a lot more current out of there. So higher voltage, higher current applications here than when you were on this particular battery here. So this illustrates quite nicely the concept of an electrochemical cell.